Augmented reality and construction sector. We all have played virtual games in our childhood. Ever wondered the idea behind it can be used to build structures? Being a civil engineer fascinates us to know the intriguing combo of AR in the construction sector. This video will help us go through what an AR is and its use in the construction sector. Augmented reality is a technology that integrates 3D items into the user's environment and displays them in real time. It is a type of software that's been used in video games for a long time. Building and structured data are merged with 3D models. The user wears an augmented reality gadget that orients itself to the user's point of view. In real time, the building data is presented digitally over the user's physical surroundings. It is a technologically augmented representation of the natural physical environment created by digital visual components, music, or other sensory stimulation. It's becoming increasingly popular among businesses that deal with mobile computing and commercial applications. One of the critical goals of augmented reality is to highlight some aspects of the physical world, increase knowledge of those features, and generate intelligent and accessible insight that can use in real-world applications amidst the rise of data collecting and analysis. Big data may be used to assist businesses in making better decisions and obtain insight into consumer purchasing habits, among other things. Why in construction? As time passes, civil engineering is attempting to evolve using technology and extensive field information to construct a modern-day nation. Drones and 3D items have replaced sketches, architectural blueprints, and drawings in the scene. We can optimize the product life cycle by using AR. In addition, R&D, research and development, expenses in the construction industry are often substantially lower than in other sectors. It almost seldom exceeds 1% of total income. As a result, the construction sector must incorporate sophisticated technology into its daily operations. According to the analysis, productivity has increased by only 1% each year over the previous 20 years. Based on the U.S. Bureau of Labor Statistics and the U.S. Bureau of Economic Analysis. It also offers clients and engineers a clear picture of how the project will be built. Communication with users, including showing them how their project will appear before it is completed and allowing them to make any adjustments they choose. It makes the job more accessible, more cost-effective, and faster. Application of AR in construction industry. Some of the applications which are emerging in this new field of the era are 1. 1. AR technology is used for project planning in which the clients can check their buildings. Using 3D objects on a 2D plane using 3D modeling software and building information modeling, BIM. Clients can see their building even before construction and can add some changes according to their wishes. Even the engineers can know the flaws or corrections in advance, saving time, reducing cost overruns, and involving the client in the project. 2. 2. The field workers can take automated measurements of a building by a tap-wearing AR unit and compare them with the specified building models. This foresight in the construction of buildings will ensure efficiency in the project time and avoid extra labor costs. 3. 3. Project modifications. We might not know which size of window/door can make the wall more attractive. AR clients/engineers will remove and relocate the components in the virtual view even before starting their construction work. They can troubleshoot the errors before starting the job. 4. 4. On-site project information. Users can view the project progress and information of building in the form of layers. 5. 5. Team collaboration. Construction project requires contribution from different teams like designers, carpenters, electricians, plumbers, welders, etc., for a flawless building to get constructed. AR allows us to make videos and share notes of the construction site with people who could not get to the construction site. 6. 6. Safety training. AR can stimulate hazard scenarios and equipment training to educate workers better. 7. Underground construction. When new cables or pipelines are made, there is a chance of hitting a gas line or damaging underground abilities, which might cause an explosion. Using R, we can have all critical information at our fingertips like depth, ground, cable types, etc. 8. Structure layout planning, SLP. The SLP can be extended to temporal dimensions in addition to the spatial dimensions covered in this experiment. The R applications can be augmented by intelligence in generating optimal solutions from an initial set of solutions proposed by team members. Incorporating such algorithms to capture the user experience in developing initial solutions and further optimizing them systematically is a scope. The application can be made to go markerless and based on object-based tracking to be augmented on an accurate construction site, as was done earlier in the case of visualization alone. Further, the possibility of remote collaboration using VR-based environment can be explored. Blueprints can be brought to life with VR before a single worker sets foot on the job site. The technology is already in use by McCarthy Building Companies, one of the largest construction firms in the United States. Clients can make changes to the design quickly and easily without incurring the expense and logistical infeasibility of altering physical construction. The main uses of AR here include holographic displays of BIM models, collaboration among team members, and immersion in construction plans. Developments in India. Using VR and 3D modeling, the facilities enable virtual prototyping, design reviews and analysis of virtual models, and walkthroughs for customers to give them a real-world feel of the actual project before execution. Design engineers and project teams have made considerable use of the said facilities for projects like the Hyderabad Metro and the Statue of Unity in Gujarat. Plans are afoot now to develop ways by which 3D models in VR can also be viewed outside such studios, at construction sites using wearables. SmartViscs, the year 2014 startup with more than $1.5 million in funding, is behind Trichy. Tells us about the idea behind creating India's first virtual reality platform for the architecture, engineering, and construction industry. What makes Trichy interesting is this VR collaboration, which allows the designer, the architect, the furniture manufacturer, and the CEO of a company to collaborate in real time and make changes in VR itself. This not only saves cost but also helps expedite decisions. The platform, Trichy, takes away the physical aspect of construction that eventually costs money, bring it into the virtual side of things, explains Gautam. TD adds, right from day one, it has been about solving a pain point, and we have lived those pain points that we're trying to solve with Trichy. Virtual collaboration in world. AEC projects are complex, and coordination and communication across teams and partner companies are vital at every stage, from groundbreaking to ribbon cutting. VR can help make this coordination highly time and cost effective. To launch work on a $100 million Florida high school, one construction company introduced VR to enable meetings among 4 design, field, and virtual design and construction, VDC, staff, based locally and in Chicago and San Diego. During 3 VR-assisted sessions, the teams minimized requests for information, RFIs, each of which can cost more than $1,000 and take up 8 hours of review on average. They uncovered 32 issues, as many as 4 were rated critical, including hard-to-detect constructability conflicts and oversights they could only find at a human scale. Another company, leading a laboratory modernization project for the U.S. Department of Agriculture, used VR to assemble teams from offices in Denver, San Antonio, St. Louis, and Merritt Island, Florida, into a seamless working group. VR helped these team members tour their full-scale 3D model of the project from their own offices and make adjustments before construction began. The tool helped prevent late-stage design changes and reduce RFIs, request for information. In 3 hours of collaborative meetings, participants identified and resolved an average of 7 potential RFIs per hour. It's not about civil engineers, but the architectural dreams can also be brought in AR. AR application sample used for the virtual reconstruction of architectural heritage study in the Roman city of Girona, Spain. We have already done several feasibility trials through the Laboratorio de Modelado Virtual de la Ciudad, LMVC from CPSV, Centro de Política de Suelo y Valoración of the Barcelona Tech University, which demonstrates that low-cost equipment and free applications are helpful to carry out planned research. Safety and training of professionals in AR. Additionally, augmented reality, AR, which blends the virtual and the real worlds to offer a digitalized and highly interactive version of reality, is also being evaluated for application across businesses. Having identified safety as one of the core thrust areas of organizational excellence, companies across L&T have been working overtime to foster a safety culture. they are turning to digital technology to improve employee safety standards. With a large chunk of this involving education and safety awareness, technologies like virtual reality, VR, are being used. VR-based safety training modules have been developed at several locations to familiarize workers with the risks of working in hazardous environments. One of the more exciting projects the digital team has embarked on recently involves using augmented reality, AR, by using smart glasses at project sites and using virtual reality VR gear for training workers on safety. Conclusion. Today our technology is still not in the most developed form, with hardware cost and software licensing being considerable expenses. Most of the AR applications are focused on design, safety training rather than on-site usage. Internationally, much of the AR applications concentrate on innovation and further restoration and visualization of the historic building, creating 3D archives of heritage buildings. When site engineers are seen walking around with HoloLens strapped to their faces, they are still far away. The limited use of AR in the construction industry is confined to the office spaces dealing with design, client presentations, and real-time modification and feedback. The AR industry is predicted to mature by the year 2035, bringing down cost and performance enhancements. Till then, gaming and consumer tech industry would drive its growth. Hope this video gives an insight into the AR in the domain of the construction sector, a civil engineer's point of view. This video content has been made in collaboration with Himanshu Singh, Kamini, Venkata, Sravani, Abhishek Vijayan, and Anirudh Kumar. And the video has been made by Berlin J, Hariharan B, and Abhishek Kumar.